Yeah, do you want us to explain the whole project to you, or?
Yeah, like let's see what happens.
Okay.
Yeah.
Okay. Awesome. So, like I said, it's a traffic light system, and this track over here is the simulation itself. The intersection is actually over here, and this is the traffic light. These are the two cars, and it communicates with the server. With the server right there.
Okay.
And so to go into more detail of the different components and how the communication is done, I'll pass it off to Musab.
Okay.
So basically we have three Uno Rev 2 Arduinos, and two of them are on each car, and then one to the actual traffic light.
Okay.
We also have an ESP32 middleman for speed
Okay.
between the server and the actual Arduinos. Basically, this is supposed to be an intersection. It's supposed to be perpendicular,
Okay.
but for tedious like inquiries where we have to like pick up the car and put it back into the intersection, it would have been just too much. So we just made a loop to make it look nicer.
Okay.
So now my friend's going to talk to you about the server and the actual what's going on with the hardware, with the software part.
So now you understand a little bit about the hardware aspect. I'll explain how it all communicates with each other. As you said, we have an Arduino board in here, which controls the traffic light, and at the same time, it sends the status, including the traffic light status itself and the time remaining, to this local web server we have here. And as you can see, it's a little pretty UI. And then, like you said, the Arduino boards aren't strong enough to actually quickly send all the information around. So we have this ESP32 board to make the process a little bit quicker and smoother. From there, it sends a GET request to the server, and then with the information, it sends it back to the cars, and then with the information, the cars act accordingly. As you'll see in a bit, if it's red, it'll stop. If it's green, it'll keep going through.
So as you mentioned, there were several cases on how it'll react according to the light status and the infrared sensors and how far it'll stop between different objects. So we'll just show you now how it'll naturally operate. You can see the line tracking, how it's following the line. It's meant to be a little bit slower around the bends because if it goes too fast, it won't be able to read it properly and will fly off the thing.
Okay.
You'll see over here that anytime a hand is put in front, it'll actually stop. I'll show you right now. So it'll avoid any projects. It's slowed down over here on the first one. As you would at any intersection, you're supposed to put off the gas to evaluate if it's safe to go. And once it saw that it was safe, it was green, it proceeded at its normal pace. Over here, it should be approaching when it's red. And if it doesn't turn, it'll stop over here because it's red. And once it turns green, it'll proceed normally.
So how it's detecting the red this side? Like, does it have a sensor around it?
Yeah, so the ESP32 is actually communicating the status of the light back to the vehicles, and they're reacting accordingly. So these vehicles know exactly what the status of the light is at all times.
Okay.
There's a slight delay though, however, because of the
So
Wi-Fi
it's like
connection.
pre-programmed when to stop, when to keep running, or?
Yeah, so when it's over here, it just checks the status of the light, and if it's safe, it'll continue to do so. If it's not, it'll stop.
Okay. So whenever he saw the black color, it's going to stop.
Yeah, so there's two edge cases. Basically, the first line, you'll see it slows down at every status. Red, yellow, and green, it slows down. And then the second edge is when it'll decide whether it's supposed to keep going or stop.
Okay.
It's a little bit laggy right now because we got the Wi-Fi shared by everyone, but
So he's running on Wi-Fi right now.
yeah, it's communicating through Wi-Fi. So you'll see that it'll stop between the two.
It's a little bit buggy when it comes to
So it's kind of autonomous, like you can.
Yeah, like the cars are meant to react by themselves based on different cases, and a few of those cases are like if there's something in the way, if the traffic is red. Yeah, those are the main two cases. But
So these equipments, like where did you get them? Like
these cars?
yeah, these cars are selling.
Yeah, you can buy these online. So these are the Elegoo four-wheel drive cars, and they have a lot of codes and whatnot online, a lot of information online, but I can get them online like anywhere.
What's the name of the car? Do you know?
Elegoo, it says right here.
Elegoo four-wheel drive car.
And it's four-wheel drive. If you search up like Elegoo smart car or Elegoo RC car, they have a bunch of different options. We went with this one because it met the criteria of our project. We wanted line tracking and the infrared sensor or the ultrasonic sensor at the front. So we found that it was the best car for its price, and we ended up getting it. And it works perfectly as well.
For this one, do you use any programming thing? Like
Yeah, we use an Arduino IDE to establish the communication between all three devices.
like which program language did you?
It's built on C. On C.
C.
Yeah.
Okay. Okay. Thank you.
Thank you.